Hello class, in this video we shall be discussing on one property of the colligative property. So that is, you can see on the board, it is depression in freezing point. Okay, now let us first try to know what is meant by freezing point. So freezing point is a temperature at which the vapor pressure of solid is equal to vapor pressure of liquid. So when the vapor pressure of solid is equal to vapor pressure of the liquid at that particular temperature, that is called the freezing point. Okay, now suppose we take a non-volatile solute, okay, mixed with a solvent. Then experimentally it was found that the freezing point of that solution decreases. Okay, it decreases. So now let us try to express mathematically. Okay, and yeah, one more thing is that the freezing point temperature of the solution is always less than that of the freezing point temperature of the pure solvent. Okay, so let us take TF degree as the freezing point temperature of pure solvent, and TF be the freezing point temperature of solution. Okay, now as we have discussed that the freezing temperature, okay, of the solution is less than that of the pure solvent. Okay, so therefore we can write the amount of change, okay, the amount of change, that is del TF, okay, is equal to, if we subtract from the pure solvent, okay, if we subtract TF from the pure solvent, okay, the temperature, then we will get the amount of change in the freezing point. So this is called the depression in freezing point. Okay, and one more thing, the next one was like this. Experimentally it was found that the depression in freezing point, okay, is directly proportional to the molar concentration of the solution. So experimentally it was found that the depression in freezing point, this is the expression, okay, is directly proportional to the molar concentration of the solution. So this is nothing but mole, okay, this is say molality. Okay, so del TF is equal to KFM, where, okay, KF is a proportionality constant. Okay, KF is a proportionality constant, or it is also known as the molar freezing point depression constant. Okay, molar freezing point depression constant. Okay, now the next one is, how do we calculate the molar mass, okay, from the depression in freezing point? So this is the given equation. Okay, now from here we can calculate the numerical problems. Okay, now suppose if we were asked to find out the molar mass, okay, from the depression in freezing point, then we can do this way. That is, okay, let me just remove this one. Okay, now determination, okay, determination of molar mass. Okay, so we know that molality is equal to number of moles of solute. Say for now let us take the number of B as solute component, A as solvent component. Okay, then it will be divided by mass. Okay, so mass, let us take W, a mass of solvent, multiplied by 1000. Okay, then this one we can further express it into NB is equal to mass of solvent divided by molar mass of mass of solute divided by molar mass of solute. So it will be WB by this MB will come down, so MB into WA multiplied by 1000, or say 1000 here. Okay, so instead of M we can express in this way. So therefore I shall substitute the value of M here, then I will get del T of F equals to K of F multiplied by, instead of M, I can write this one, that is WB into 1000 divided by MBWA. Okay, so here, if we are asked to find out the molar mass, okay, of the solute, then with this equation we can find out the molar mass of the solute. Okay, so this is the expression for the, okay, depression in freezing point. Okay, let us see the question here. 45 gram of ethylene glycol is mixed with 600 gram of water, which means ethylene glycol is solute and water is the solvent. Calculate the freezing point depression. Okay, freezing point depression, which means we are asked to find del TF, and the other one is the freezing point of the solution, that means TF we are asked to find out. Okay, now the given values are WA is equal to, this is of the solvent, okay, so WA equals to 600 gram, WB is equal to 45 gram, and KF is given as 1.86 Kelvin kg mole inverse. So first we shall find out del TF. Okay, so we know del TF is equal to K of F into WB into 1000 divided by MB into WA. Okay, so MB is the molar mass of the solute. Okay, so molar mass of the solute I have separately calculated already. Okay, so maybe you can write down just below this one. Here you can calculate molar mass, okay, and write down. Okay, so I have written here already. Okay, now what we do is we put the values of these things. So KF is 1.86 into, okay, right now, for now I am not writing any of the units. Okay, WB is equal to 45 gram into 1000, okay, divided by, this one will be 62 multiplied by WA is 600. Okay, and we shall calculate this one. So on calculating this one, we will get around 2.25. okay, we will get around 2.25 Kelvin. So hence the freezing point depression is 2.25 Kelvin. Okay, then, okay, you can write down here freezing point. Okay, therefore freezing point depression is equal to 2.25 Kelvin. The next one is we have to find out the freezing point of the solution. So we know that del TF is equal to TF degree, that is the freezing point temperature of the pure solvent minus the freezing point of the solution. Okay, here what we do is you bring this one this side, so TF, bring it here, and TF degree minus del TF. Okay, so we got this one, that is here. We have to find out this one, and this one, it is not given here. Okay, but remember that, okay, one thing we must make sure, see, this is the freezing point temperature of the solvent, and here the solvent is water. Okay, and we know for water the freezing point is 273.15 Kelvin. Okay, or 0 degree. Okay, at 0 degree the water freezes. Okay, so therefore this will be known to us. Okay, so TF is equal to, this is the value, 273.15 Kelvin minus, okay, this one is 2.25 Kelvin. Okay, now if we subtract this one, we will get around 270.90 Kelvin. So therefore the freezing point temperature of the solution is 270.90 Kelvin. Okay,